Alright guys, so I'm going over a couple more problems here. One of the ones I kept getting asked on was like on number 5 here. They're asking which is the equation. And again, I want to show you just a couple things here. To be smart when you're going through problems like this. I mean, look at these. They all have -3s here, which has to do with the downward shift. So, I mean, I can see that the center line moved 1, 2, 3 down. But it's not even something I would have to really even pay attention to, just because, I mean, they all say that, okay? If I look over here, these are all 2's in front, which means from the center I went up 1, 2, 1, 2 down. That's just the amplitude. And again, not something I have to worry about because they all say that. What does matter is this sine or cosine, okay? So, well, I don't have that right in front of me, but the sine graph, let's say that this was the origin, would look like this. Okay, and then it keep going up and down, up and down. This is sine. The cosine graph looks like this. So really what happened here is they're telling me I have a phase shift. Okay, and if this is the way the original equations look, like even though I moved this thing down, the cosine graph would still start right here at the origin. All of these indicate that there's some sort of phase shift. And so since this is up here, that would mean if it were the cosine graph, this point right here would have shifted this way. And that's not the case. So that's why I scratched out the 2 cosine ones. I know it's not that. It has to be the sine shift. Now, so the sine is starting here at the origin. And again, we moved it down already. So it's right here. And now I have to decide to move left or right. So I have to know that the sine graph goes up. And so what I'm noticing here at this point, this is where it goes up. So it's not over here because if had it moved to the, so I'm saying it shifted to the left. Had it shifted to the right, then the graph would have looked like this. Something like that, okay? But because it's this way, that means it shifted to the left, which means that this is a plus sign, excuse me. Oh, I marked the wrong one. I'm sorry. So a plus sign means I shifted to the left, so the answer here is A. Not C, sorry. My fault. Okay, so moving forward, another problem that I had a lot of questions on, or that you guys were asking me a lot of questions on, was 36, this one right here. So I want to go through it just so y'all can see it. So this is my original equation. I went ahead and rewrote it and made another graph here so I can go through it with y'all. So this is my A value, B, C, and D. Now, the reason I wanted to go over this one also is because the B value, when I actually write it, when I talk about phase shifts and all that, let me erase this right now. I need it to look like this, outside the parentheses. So for that reason, I'm going to go ahead and rewrite it like that. A, F, and then the B I take out, which this is a theta or an X. So the B value is 1/2. And the C value does change. So I'm going to take pi divided by 2 and divide it by 1/2. Okay, so this becomes theta over 2 times 2 over 1, which is equal to pi. So my C value is pi, because again, when I redistribute this, 1/2 times pi is equal to pi over 2. Okay, and minus 1. Okay, so my amplitude here is 1/2. It's just this value. Remember, the period's what I'm what I'm worried about. So 1/2 divided pi, 2 pi divided by 1/2, because it's 2 pi over b, which after I simplify this is, excuse me, equal to 4 pi. So a period is 4 pi. Phase shift is the C value, pi, and since it's a plus sign, I move to the left. And my vertical shift is 1 down because it's negative. So as I start to graph this, okay, remember I'm dealing with the cosecant graph. So cosecant, guys, is related really to the sine graph. So I'm going to start with the sine graph, and then from there, that's where I can show you what the difference is between cosecant and sine. So let's go ahead and draw our little boundary here. So I'll start down here. my vertical shift is 1 down, so this is my new center line, 1 down. My amplitude is 1/2, so I drew these in terms of half, guys. So this is my high point. This is my high point. Okay. And then I move down to the period, which is 4 pi. So from 0 right here to 4 pi. Now, so I know that this is it, but I'm moving it by pi to the left. So by one little dot this way. So my boundary is in here, and since this is kind of dealing with the sine graph, I know that it starts here and it ends here. So it goes up, comes back down, something like that. So okay, like I said, that's the sine graph. The cosecant graph, I'm gonna go ahead and make this a boundary here. It touches this same point here, these same hills, but now it goes up. So the answer for cosecant and sine is, and secant is the sine or cosine graph, but they look like this. So, and I would see that this pattern keeps continuing over and over here. So just to go through it with y'all, a lot of y'all were asking about it, so there it is. Okay, next problem. Number 4. So this is it right here. Find the exact value of cosine 5 pi over 12. And so I don't have a unit circle on me, but if I were to look on the unit circle, 5 pi over 12 would not be on there. Okay, and so first thing I'm going to do is convert this into degrees, which I'm doing right here. So 5 pi over 12 multiplied by 180 over pi, and it equals 75 degrees. Okay, again, 75 degrees not on the unit circle, so this is where I have to use the sum and difference identity. So here, what I did is I took cosine 75 and I divided it. 30 plus 45, it equals 75. So I'm using sum and difference identities, these right here, where I'm saying that my A value is 30 and my B is 45. Okay, so I got this equation because I'm dealing with cosine A plus B, and this is my equation right here. Okay, so that's what this is. I use U and B, guys, because that's the way I introduced it to y'all, but it's the same thing, A and B. So I have cosine of 30, cosine of 45, minus sine of 30, sine of 45. Oops, I wrote V instead of 45. Okay, so all I'm doing here is I'm multiplying. So you look at your unit circle, if you go to 30 degrees and you go to cosine, which is the x value, it's going to be square root of 3 over 2. Again, cosine of 45 would be square root of 2 over 2, okay, and so forth. That's where I got these numbers from. And I did a little shortcut here, but because I'm looking at the answer choices, they factored something out. And so what I see here is the denominators here are going to be both 4. So I'm going to just leave it like that, square root of 3 times square root of 2. And minus 1 times square root of 2 over 4 and 4, right? Because the bottom is just 2 times 2. Excuse me. And if I keep moving forward here, guys, I could say this is square root of 3 times square root of 2 minus 1 times square root of 2 over 4, because they have the same denominator. And I see that they both have square roots of 2. So I can say it looks like this, which is answer choice C. Again, guys, I paid attention to the answer choices before I moved on, because had I not, I would have just went ahead and said square root of 3 times square root of 2, square root of 6. But since the answer choices don't say anything square root of 6, that's why I had to mess around with it like that, okay? Alrighty, and I think the last one I'm going to go over here with y'all uses the sum and difference identities also. Very difficult question. I don't know why this is so hard here. But find the exact value of 2 cosine 15 degrees, 2 cosine 75. So essentially what you're doing here, guys, is I went ahead and I'm not going to go through every single thing here. I just want to explain what's going on. 15 degrees is saying 45 minus 30. 75 degrees is the same thing as saying 30 plus 45, which we just did. Okay, so if I continue this problem, what I did is this point right here, I'm using the sum and difference identity, cosine A minus B, which is this equation right here. That's what this is. Cosine 30 plus 45, that's the sum and difference identity again, now with a plus sign, so this equation right here. So essentially here, then I just start plugging in numbers, and after I do a bunch of algebra, you can see I made a little bit of a mistake here myself, I end up with the answer of 1/2. So go through it slowly, but that's what I'm doing. I used sum and difference identity once, and then second time, and then I multiplied by 2. So that's it for this video, guys. There's going to be one more regarding proofs, and just study.